Welcome back, everyone. Today we are going to be revisiting our fun math series, Math for Fun, in other words. And today we're doing a part 2 of integrating ln cubed x by parts, using the integration by parts formula. So let's just continue. Today we left off from, since we actually got the general formula for, or not the general formula, but the general composition of, let me just get this here, the general composition of the actual formula, or the actual math itself. Since here what we did was we actually calculated this here, that, and basically what we needed to do here was to integrate the natural log of x squared dx. And to do that, well, obviously we're going to use integration by parts again. So this here is where we left off. So we're just going to use the same method. So we're going to set u equal to, and we're using chain rule again, ln of x squared, thus making du equal to, this would just be 2 times ln of x times the derivative of ln of x, which is just 1 over x. You differentiate the outside and then the inside. Okay, so now, since we got that, we can actually find v and dv. So let's do that. So our v, actually, well, I do dv first. Dv equals, well, dv is just, obviously, since there's a hidden times 1 there, it would just be 1 dx, or just du equals dx. And thus making v, once you integrate 1 dx, you get x. So v equals x. So nothing new there. Let's put into the integration by parts formula. So we write it out. The integral of ln squared x dx equals v times u. So x times ln squared of x minus, sorry I'm using Christmas colors, I don't know, it's completely random, minus the integral of v du. So x du, which is just, oh, and also we multiply 1 over x times x, so let me just write that out. So you just, again, like that other time, you cancel the x's, just get a 1, and that doesn't matter since we're not adding or subtracting, so that can just go away. So this is gone now, and we don't have to worry about the 1 over x, or the x. And all we're left with is, actually, let's just straight up take out the 2 from the formula. So we're taking out the constant here. Okay. So minus, and then we're left with ln of x. So now, I think this was rather quick, so I think I'm actually going to just do this all in one video, integrating ln of x. We'll see about that. So all we have to put is ln of x dx. Right, and that is our formula. So I'm going to put a rectangle around that. That's a bad rectangle, so I'm going to redo that. Okay. Now we have to integrate just ln of x. And that will finally be the last step. So we're going to use the integration by parts formula method one more time. And then we'll get it. Okay. So, let's get started. Let's finish this up. So integral of ln of x dx. So let's try finishing this quickly. So we're setting u obviously equal to ln of x, and du being 1 over x. Okay, got it? We all know that the derivative of ln of x is just 1 over x. It's just something you should memorize. dv is again going to be equal to dx, or 1 dx, and v is just equal to x, right? Nothing special there. Okay, so now just plug this in. So we get the integral of ln of x dx equals v u v, so we get v times u. So we get x times ln of x minus the integral of v du. Times 1 over x. With respect to x. Okay, and obviously we can tell that these terms cancel out. So we're left with the integral of 1 dx. And we all know, everyone knows this, of 1 dx. And everyone knows that this is equal to x, so minus x. So let's just erase this. So we get minus x. Okay. Oh, don't forget the plus c. Okay. So that is our answer for ln of x. Sorry that I didn't put the plus c for the other ones. I just found it unnecessary since we didn't have it completely simplified. So now we can just plug this back into this formula here. Probably should make that more clear. This equation here, ln squared of x dx, the integral of ln squared of x dx is equal to x times ln squared of x minus 2 times the integral of ln of x dx, natural log of x, dx. So now we can just plug that in for, plug this, just plug this part in for what we got here. Okay, so let's write it out. Let's cover that. Okay. Just to keep things tidy, even though it's not going to be very tidy. Okay, so now we can write out. I'm going to start using all black now because that's going to take less time. Ln squared of x dx is equal to, get rid of this, x times ln squared of x minus 2 times what we got here. So 2 times, should we distribute the 2 or, you know, we probably should. Let's see. guess we can just straight up distribute the 2. It's actually distributing the negative 2, by the way. So it's just minus 2x ln of x plus 2x plus c. So this is our answer for this one. And we're just ignoring the c because it's kind of trivial to just ignore the c, since taking the derivative of that again will just result in 0. So this is our solution for ln squared of x dx. Now let's look at the final step and plugging this back into, let me write this a little nicer. Sorry about that. Just going to make that look a little nicer. Okay. Sorry about that. Just need to redo that now. So minus 2 minus 2 times ln and x times ln of x plus 2x plus c. Okay, so now since we got that, we want to take this and plug it back all the way back into this, or this equation here. Okay, going to have to go back and forth a few times. So finally, the integral of ln cubed of x dx is equal to ln, hold on, let me make sure I did that correctly. Okay, I did it. Okay, is equal to ln cubed of x, so let's just write it as x times ln cubed of x minus 3 times what we got here, right above what we're doing here. Minus 3 times, we'll instantly just distribute it. 3 times x times ln squared of x plus 6 times x times ln of x minus 6 times x plus c. And that is our final answer, right? That is our final answer. Let's see if we can make it look a little nicer. We can actually, we can take out an x from that solution. So let's finally write it as equals x times ln cubed of x minus 3 times x, oh, whoops, I took out the x, right? Minus 3 times ln squared of x plus 6 times ln of x minus 6 plus c. There we go, and that is our answer. So we just took out the x, right? And there we go. So hopefully you enjoyed that video. I thought it was quite fun, and you'll see more from this Math for Fun series. So hope you have a nice day, and see you in the future.